成果非常に頑張りましてですね、面白い結果を得ておりますので、今日は帰る前に報告してもらおうと。位置づけですけどもね、多分本人はあんまり自慢して言わないと思うんですけども、確率で大事なことは、ノイズの関数として表される、偶然現象。それはパラメーターが、従来は時間のパラメーターばっかりで考えているのが多かったんですけど、最近は少し空間のパラメーターを考えなければいけないと。もともとそういうことは基本的に分かっていることではありまして、古くはハーマン・ワイルのナオサイトマテリアなんかもあるわけですけども、特に最近空間をパラメーターにするようなノイズ、それの関数を考えるということが大事になってまいりました。で、空間だけでノンカオスというのはまずやらなきゃいけないことがあったんですけど、それはポール・レビンの50年代の表現がありまして、これ誰もフォローしないんですけど、シシさんが帰る前にしばらくやっておりまして、今回の話もそれを参考にして発展させているという面はありますけど、でもう一方、その時空の両方にディペンドする場合、これはガウスですけども、先日ぐらいお話ししている KPZ の方程式がある、いずれにしましても確率の方程式の似た格好をしてますけれども、そうではなくてですね、スペースをパラメータにするようなノイズ、だから、空間の点が違いが独立になるようなアイデアライトなランダムベリアブルのシステム、それの関数として表されるシステムを考えるということが、重要な課題になってきています。で、実際、よく言われているのはガウスで時間定というのがほとんどなんですけど、新しい視点とそれから結果もですね、現在のところリニアなシステムを考えておりますけれども、いずれはノンリニアに行くそうになっております。で、そういう意味で新しい方向の、基本的な一つの成果を出してもらったと、短い時間でしたけども非常に頑張りましたので、せっかくの機会だからここで話をしてもらったらというふうに思っております。以上。日本語で英語にする。
皆さんこんにちは。私台湾から来た張と申します。よろしくお願いします。その1年間皆さんいろいろお世話になりました。本当はありがとうございます。今日は私の1年間の研究報告の発表します。特別来た先生の感謝します。でもこれから私の日本語まだ上手です。今日本語上手じゃない。それから今英語を使います。お願いします。Recently we have a very fashion movie. The topic is Lucy. The Lucy movie talk about a lot of the biologics and physics and a little bit of the mathematics. In the movie Lucy, the main character said, "Do you think about 1 plus 1 is equal to?" But in reality, really 1 plus 1 is equal to 2? Yeah. But have you ever considered about 1 plus 1 maybe be 2 squared? Yeah. it may be happen in some quantum physics and probabilities. Because maybe something like we cannot see the things make it work. The その見えないのことを to 使いやってみます。多分。So in my paper, whole is try to think about the things we cannot to see. It's about lambda. The lambda is intensity. But the lambda we cannot see. But how do we try to research it? We just try to discriminate it for this end. To discriminate, we relation it to a jump u. You can take it express it as a jump. And you can see it's a label. Or even in the lattice type distribution, it can be a span. So we have to use the jump u to investigate the intensity lambda. In the natural phenomena, we cannot see the lambda intensity, but we can see the jump u. So sometimes in the paper, we try to use the p lambda, p prime lambda, and it can be used to be p from u because we mentioned about lambda and u has the one-to-one isomorphism. But actually, p from u means p from lambda. So we focus on the p from u is our main research role. In the natural phenomena, we are based in we have freedom to choose the lambda, but the jump u may be different, but the lambda may be the same. Like the thing we see is different, but naturally maybe it's the same. And we also, in the university, we learned about the ozone process, the BT lambda. The BT lambda, we can see it has a duality from T and the lambda. And in my paper, I try to fix the T is equal to 1, and we can just focus on P lambda to research about it. But we already know about a lot about proton process, but most people think the proton process is discrete. But we try to use the Levy's idea in Levy's book. Levy said the better important than discrete. We have to try to consider about the continuous many. Independent case. It's more importantly the discrete case. So we use the P prime lambda to investigate the continuing many independent case. It's like the analog way to the method to investigate. So when we in the calculus, we know about like from 0 to infinity f(x). We may consider about its definite integral. So it may be a constant. And like the many people try to think about the f in the Levy's book. People may think about it's like a constant, a definite integral, but it's lose the really meaning about the continuous many independent meaning. Because if we try to take the xu, it's the integral from 0 to u f. We may consider the u and xu is analogous to the polynomial I from e to n. This can be like the continuous polynomial. Yes, so in my paper I focus on the formula like the integral, but actually it's the continuous polynomial. In the common sense, people know the standard noise, like it depends on the time and the space. Depend on the time is like the Gaussian and Poisson process. It depends on time. But in my paper, I depend on the space. So I focus to investigate the space noise. The space noise, because we cannot see the lambda, so we use the jump U to investigate it. But actually, in the topology, we cannot use the L2 like the Hilbert space. Because we don't have the L2 node to use it. So we don't know how to investigate it. So in the topology, because it's convergence in the probability distribution, so we can not use it to easy to compute. So we depend on the characteristic function. Just focus on the cause easy to investigate it, because it's easy to calculus and it's on the real line R1. It's very easy to compute and calculus. So like a movie has the whole characteristic main character main role. The characteristic heuristic function is my paper's important role in my papers. So we are interested in the random system that comes from the noise depending on the noise variable. But unlike the Gaussian white noise depend on the time, we depend on the space parameter. So we use the Poisson type to investigate the space noise. It's P prime. And we use the P prime lambda to give the linear system and the linear function. And more general is so it's from the reference in my paper, Levy's 1 and 2 reference. And Levy told the linear functional is correlated linears. It's about range. But let's go so 難しい。And what I told about in the span is the lattice type distribution. What's the lattice type distribution? It's a discrete distribution of the interval. Yeah. So like what we know